So, like, just going through the Tesla mission. Obviously, the Tesla mission is to accelerate the transition to sustainable energy. So, obviously, it's incredibly important that we do that. It matters to the world. It matters if it happens sooner or later. It matters if it happens at scale. And that's what the Gigafactory is about. It's about being able to make enough electric cars, enough stationary battery packs that it actually moves the needle from a global carbon production perspective. So that it actually does really change the world. So that's why it has to be big, because the world is big. Okay, that's why. So the crazy thing is, like, what you're seeing here is actually only 14%. It's 1/7 of what the completed factory will be. But we've been able to increase the output of the factory compared to the original design by a factor of 3. So ultimately, we think that the factory will produce about 150 gigawatts, and we'll talk about that. Yeah. So, all right. So, starting with what's needed for the Gigafactory is the Model 3. So, this is really about being able to make enough cells, enough batteries to make hundreds of thousands, ultimately millions of electric cars, and to do so at a massive scale, and in a way that is affordable to people. So it doesn't matter. I mean, cars obviously need to be affordable. Otherwise, people can't bloody well buy them. So in order to achieve that, there are really two key dimensions that are necessary. One is to keep iterating the technology, to design the technology to be better and better, and have multiple versions. And so this would be our third major generation of technology, and then economies of scale. So we're driving those to the absolute maximum with the Gigafactory, and that's why it's so big. It's big for a reason.
There just wasn't enough factory capacity anywhere else in the world. We didn't have an option. This factory will have the output of all the lithium-ion factories combined when it's done.
Yeah. Yeah, exactly. The basic math was that in order to make 500,000 cars a year, we would need every lithium-ion battery factory on Earth that makes batteries for phones, laptops, cars, everything, just to achieve that output. So it's like, well, clearly that's not being built, because you'd be able to see it on a satellite picture. Okay. So either we figure out some way to build this thing, or there will not be the cars that are needed. So we kind of just said, okay, we got to just start building this thing, and hopefully people will buy into it and start to believe. We're only able to do this because of you guys. So it's without you, this could not be possible. So I just want to say thank you very much. In order to achieve this, we really had to design the factory as a machine. So a lot of the way that people look at factories is kind of, it's often thought of as kind of like a boring thing, like making photocopies or something. It's just like boring, it's like catalog engineering. But this is totally the wrong way to look at it. You really need to look at a factory like it's a product, like it's a giant machine that builds the machine. And it deserves actually more innovation and more engineering skill than the product itself. And that's what we've done with the Gigafactory.
Yeah, we have some of our best engineering teams working on actually laying out the factory and looking at how to fit more density and more equipment into the same footprint. And this is really key to how we've been able to reduce the cost of the cells and the batteries that come out of here so much. That intense engineering effort is what drives this improvement. It's not just, as Elon said, it's not a copying machine. It's not just replicating things that have been done before. We're reinventing that battery manufacturing process from end to end.
Yeah, in fact, I can't emphasize enough how important this conceptual framework is. Because really, almost everywhere, they just think of the factory as a bunch of machines, like basic machines that are stuck together to produce copies. And it's mostly pulled from catalogs. You'll get this machine from that person, that company, this machine from another company. But if you applied that same principle to product design, it wouldn't make any sense. Like if we try to make the Model S out of parts from a bunch of different cars, it would be ridiculous. It would be like, a bumper from a Honda, a steering wheel from this, a motor from something else. It would look like a right, exactly. It wouldn't make any sense to actually make a car from bits and pieces of other cars. You really need to design the car as an integrated product from the ground up. And that's the same approach we've taken to the Gigafactory, and it's really quite unusual for that to be the case. So, yeah, and then in terms of analyzing how the factory should work, I'm a big fan of using physics as an analytical framework for physics. Yeah. Physics is true. Everything else is debatable, and even physics is questionable. So designing the factory from physics first principles means really optimizing the density of the factory. So you can think of like the fundamental efficiency of the factory is the density of useful stuff. Like what percentage of the volume of the factory is actually useful stuff versus not useful stuff. And then the output of the factory is the exit velocity of products from the factory. So we're actually just applying that throughout, or through every step of the process. We're actually fairly confident that there's at least maybe a 5 to 10-fold, at least 5, I think, and maybe 10 or more fold potential improvement in production capability.
And this image you guys can see, maybe some of you can see on the screen, is actual CAD of the factory. Just like a great machine, the entire factory is in CAD. Every pipe, every electrical conduit, every piece of ductwork, and every piece of equipment building the cells. So we've modeled all that to fit it in, with the minimum wasted space. Everything is basically almost touching each other on every floor. So that was necessary to build this amazing machine. And many factories aren't done this way. They're just, you build a shell and then you sort of randomly put equipment in there. But this was very different.
Yeah, it's essentially designed like a very high density, multi-layer integrated circuit, like an advanced CPU, which is really, actually when you think about it, it's like obviously how it should be done. And I think actually over time, the manufacturing process may look a lot like one of those super fast chip pick and place machines. It's super optimized for speed and density. If you think about like, how did we improve the capability of your phone or your laptop? It wasn't by making a really giant computer the size of a table. It was by increasing the clock speed and the density. And those same principles apply to manufacturing. So I'm really excited about revitalizing manufacturing. I think it needs love, and we're going to give it. Yeah, go ahead.
And we're also expanding the scope of what people typically thought of as a battery factory. We're going all the way from the basic raw materials that go into making up a cell, all the way through to the finished battery packs under one roof in this single factory. Historically, it's gone between a lot of different factories.
Yes, it's a three-step process, which we've outlined for you. All of our secrets are right here. Raw material, bunch of stuff happens, out comes a car. So the vertical integration it's pretty important because one way to think of manufacturing efficiency is how long a journey did that molecule take from when it was mined. So if it was mined in one part of the world, then went halfway across the world to get processed, then back halfway across the world to get processed another way, and eventually does several trips around the world before it finally ends up in a finished product, that's obviously just that's fundamentally going to be expensive. It's like you just can't send things on round the world trips and expect it to be cheap or affordable. It's just not gonna happen. So it makes sense ultimately for rail cars of raw materials to come in one side, and then for finished vehicles to exit the other side. So, today it's sort of split up. We've got the vehicle factory in Fremont, California. We've got the battery factory here in Nevada. But I think for Gigafactory 2 and beyond, I think we're just going to integrate that into one big facility. Yeah.
And just to give you a sense of scale, I think you guys have seen the models. Hopefully many of you have gone on tours, but to make it sort of more real, this factory is going to be about 6 million square feet of ground area when it's
That's
completed.
just the footprint, yeah.
It's just the footprint.
It'll be the biggest building in the world, biggest single building in the world by footprint, and second only in volume to the Boeing factory in Washington State. Yeah.
It's really, really huge. And if you sort of think of something that maybe you're familiar with, like a 747, that's pretty big, right? Well,
right.
We can fit about 100 747s parked in the footprint of this building.
Yeah, and I mean, not only that, I mean, we can fit 50 billion hamsters. So, but in terms of vehicles, we actually expect to get to 50 gigawatt hours a year of output in 2 years. To give you a sense of what that size is, total global output, I don't know the 2015 numbers, but the 2014 numbers for total global output of lithium ion for all purposes throughout the world was only about 30 gigawatt hours. Okay, so this is more than the entire planet produced in 2014. Maybe it was obviously more last year, but still, figure roughly this one factory will produce as much as the rest of the world combined. Yes! And then as we get to a couple years later, perhaps 2020 or thereabouts, we expect when the factory is fully built out. And like I said, you're actually standing, where you are right now is the middle of the factory. You're standing in the middle of where the factory will be when it's complete. So we should have another party, I think. And so we figure when it's done, it should be able to do on the order of 1.5 million cars, and also provide a lot of power for stationary storage for battery packs, which are obviously going to be very important to pair with solar.
And all this is happening a lot faster than we even initially planned it could. With the amazing results from Model 3, we've pulled ahead that 500,000 cars by fully 2 years. So the building you see outside is almost doubling in scope just by next year in order to build those 500,000 Model 3s per year.
Yep. So, yeah, it's super exciting. I actually really love manufacturing. It's great. It's like more people should get into it. But part 2 of the master plan. So there's 4 parts to it, which is to make beautiful solar combined with battery storage, to expand to all of the major vehicle segments in order to, as quickly as possible, move us away from oil. Get to a self-driving capability that's about 10 times better than the average driver. So I mean, that's a lot of lives saved. So 1.2 million people die a year in auto accidents. So that's a lot of potential for lives saved there. And then the ability to add your car to a shared fleet whenever you want. So whenever you're not using your car, you'll be able to just tap the Tesla app on your phone and add it or subtract it to the shared fleet. And you'll be able to define, like, well, who can use it, like only 5-star users or anyone or only family or whatever. And then whenever you want it back, you can just tap it and it will return to you. So. So most of the time when you look at cars, they're sitting in a parking lot somewhere, and they're not being used. And this has the potential to massively amplify the utility of vehicles and offset the cost of ownership. And it'll be totally up to you when you want to do it or not do it. It's all yours. It will find it will find Pokemon for you. Absolutely. Of course.
And As we said earlier, a lot of people, really doubted that there would be enough demand, to even make a factory like this make sense in this time frame. We started this, way before the Model 3, launch event, before we had all those reservations, and I think, it's really a tribute to all of you guys as customers that are making this possible. So yeah, really thank all of you for doing this.
So, I mean, that's basically the overview of the Gigafactory and what we're up to.
There's a lot of stuff to do already on our plate, but I think we better wrap it up with that. So
yeah.
Thank you guys very much. This is awesome.
Thank you very much.
We really appreciate it.
All right. And so this would be our third major generation of technology, and then economies of scale. So we're driving those to the absolute maximum with the Gigafactory, and that's why it's so big. It's big for a reason.
There just wasn't enough factory capacity anywhere else in the world. We didn't have an option. This factory will have the output of all the lithium-ion factories combined when it's done.
Yeah. Yeah, exactly. The basic math was that to make hundreds of thousands, ultimately millions of electric cars, and to do so at a massive scale, and in a way that is affordable to people. So it doesn't matter. I mean, cars obviously need to be affordable. Otherwise, people can't bloody well buy them. So in order to achieve that, there are really two key dimensions that are necessary. One is to keep iterating the technology, to design the technology to be better and better, and have multiple versions. Increase the output of the factory compared to the original design by a factor of 3. So ultimately, we think that the factory will produce about 150 gigawatts, and we'll talk about that. Yeah. So, all right. So, starting with what's needed for the Gigafactory is the Model 3. So, this is really about being able to make enough cells, enough batteries to make. From a global carbon production perspective, so that it actually does really change the world. So that's why it has to be big, because the world is big. Okay, that's why. So the crazy thing is, like, what you're seeing here is actually only 14%. It's 1/7 of what the completed factory will be. But we've been able to. So, just going through the Tesla mission, obviously the Tesla mission is to accelerate the transition to sustainable energy. So obviously it's incredibly important that we do that. It matters to the world. It matters if it happens sooner or later. It matters if it happens at scale. And that's what the Gigafactory is about. It's about being able to make enough electric cars, enough stationary battery packs that it actually moves the needle.